question number 7, a point P that is 5, 4 and Q that is 1, 2 are points on the equation of a perpendicular bisector of PQ, giving your answer in the form of y is equal to mx plus c. Therefore, this is the line that is PQ. There is a perpendicular bisector that is bisecting this line at a given point. So, this perpendicular bisector meet line PQ at the center. So, we can find the point here. Can we find the point of here? We can use x1 plus x2 divided by 2, y1 plus y2, then divide by 2 so that we get this point, since the perpendicular bisector bisects this line at the center. So for this one will be 5 plus -1 divided by 2, therefore -4 plus -2 divided by 2. So for this one will be 2, that is -4 plus -2, that is -6 divided by 2, that is -3. So therefore, this point here is 2, -3. Therefore, we need to find the gradient of this line, the perpendicular bisector. How do you get the gradient? We need to find the gradient of line PQ. Therefore, we can use the relationship, the product of these two, the gradient of these two lines give us -1. Therefore, finding the gradient of line PQ is equal to change in y over change in x. Therefore, it is -2 minus, that is plus 4 over, that is -1 minus 5. This one is the same as 2 over 6, which is the same, -6, which is the same as 1 over -3. Therefore, getting the gradient of the perpendicular bisector will be 1 over -3 times m2 is equal to -1. So therefore, m2 is equal to +3. Therefore, we have 3 and this point. You can find the equation of this line will be 3 is equal to y minus 3, that is plus 3 over x minus 2. Therefore, for this one will be y plus 3 is equal to 3x minus 6. Therefore, y is equal to 3x. If you take 3 to the other side, will be negative, so it will be -9.